Hello and welcome to Lesson 9, Working with Line Plots. Let's get started. Okay, so we have looked at line plots before. Line plots are not something that is brand new. We are going to focus on looking at our line plots and being able to answer some word problem type questions about the line plots. We are also going to be focusing on using the things that we've learned about fractions, like adding and subtracting and multiplying fractions. Use those concepts when answering the questions about the line plots. Here is our first line plot. Time spent watching TV during the weekend. So the first thing we need to always do is read the title of our line plot. Then we need to look down at the bottom and we need to understand what the numbers at the bottom stand for. So in this line plot, the numbers at the bottom stand for hours, the amount of hours that one person spent watching TV during the weekend. Each X stands for one person. So the first thing I want to do is I want to look and I want to see how many people spent each amount of hours. So for example, how many people spent 0 hours watching television? How many people? Well, there's 2 X's, so 2 people. 2 people spend 0 hours. How many people spent a half an hour? This is 1/2. 1, 2, 3, 4. How many people spent 1 hour? 3. How many people spent 1.5 hours? 1. How many people spent 2 hours? 3. And how many people spent 2.5 hours? 1. Let me pause right here for a second, and I'm going to give you a couple seconds. You need to make sure that you have pencil and paper with you, as always. Get pencil and paper, please. And make sure that you're following along. The expectation here, I do not need you to copy the line plot. You do not need to do that. However, when I am reading the questions and I'm writing equations to solve the questions, that's what you need to do. Okay? You need to be ready to debrief about these questions when we meet. So our first question is, how many people spent longer than 1 hour watching TV? How many people spent longer than 1 hour? Well, longer than 1 hour, these are the times that are longer than 1 hour. Here's our 1 hour, and these are the times that are longer. So how many people spent longer than 1 hour? I need to count these up. 1 plus 3 plus 1. That's 3, 4, 5. 5. Easy peasy, not too bad. How many more, I see this phrase, how many more, because that phrase means something, how many more people watch TV for half an hour than 2 hours? This phrase means to subtract. Subtract. How many more people watch TV for a half an hour? Well, let's find out that. How many people watch TV for a half an hour? 4 people did. How many people watch TV for 2 hours? 3 people did. So how many more people watch TV for a half an hour than 2 hours is going to be 4 minus 3. 1. Simple. All right, let's look at question number 3. What is the difference? Here's another word that I know means something. Difference means subtract. What is the difference between the greatest number of hours spent watching TV and the least number of hours spent watching TV? Okay, here's where people make a mistake, because you see that 4 people are up here and 1 person is over here, and you say 4 minus 1 is 3. The difference is 3. No. that's not what they're asking. If you did 4 minus 1 is 3, you would be subtracting the amount of people that watched it for half an hour minus the amount of people that watched it for 2.5 hours or 1.5 hours. We're looking for what is the difference between the greatest number of hours spent watching TV. So what's the greatest number of hours spent watching TV? What's the greatest number of hours spent watching TV? The expectation is you're answering my questions when I ask them. I know I may not be right here to hear the answers, but saying them to yourself or out loud or to your stuffed animal or whatever really helps. So what is the greatest number of hours spent watching TV? 2.5 hours. So what is the difference between the greatest number of hours spent watching TV and the least number of hours spent watching TV? And the word difference means to subtract. So that's my subtraction problem is 2.5 minus 0. Well, if you're taking 0 away, then it's 2.5. Sorry. There you go. All right. We're on question number 4. How long did all the people surveyed watch TV combined? Now, you're going to have to add up all the hours the people watched combined. So, again, do not make the mistake of adding the 2 plus the 4 plus the 3 plus the 1 plus the 3 plus the 1. That would mean that you are adding up all the people that watch TV. That's not what it's asking. It's asking how long did all the people surveyed watch TV combined. So we need to add up the amount of hours. So for example, 0 hours. 2 people did that. So that would be 0 plus 0. We're not even going to write that. We don't need to write down 0 plus 0. 0 plus 0 is 0. Half an hour. How many people watched half an hour? 1, 2, 3, 4. So that means, and I'm going to write up here because I don't have a lot of room. That means that we have 4 of them. A half plus a half plus a half plus a half. Now, you know what? I don't have a lot of space. I'm going to erase that. How can I just make that short and easy? If I'm doing repeated addition, I'm adding up a half 4 times. How can I just make it easier and write it as a what? Write it as a what? I can write it as a multiplication problem. We're going to write it as a multiplication problem. So we've got 1/2 times 4. We did 1/2 4 times, and it equaled 4 halves. Okay, so that takes care of the halves. Okay, so what we're going to do here is we're going to add up each amount, and then we have to go back and add all of those together. So how many people spent 1 hour? 1, 2, 3. That's 1 plus 1 plus 1. 1 plus 1 plus 1 is 3. How many people spent 1.5 hours? 1. So that's a 1.5. How many people spent 2 hours? 3. 2, 4, 6. How many people spent 2.5? 1. So that's 1, 2.5. Now here's the deal. The way I wrote this, I can't add those up together. I don't have it lined up right. You've got to line up the fractions and the whole numbers. So I'm going to come over here and I'm going to line it up correctly. I have 4 halves. That's a fraction. I have 3. That's a whole number. I have 1.5. 1.5. Notice how my 1 is under the 3 because they're both whole numbers, and my half is under the 4 halves because they're fractions. I have my 6. I'm going to put that under the whole numbers. I have my 2.5. Okay, I'm going to erase this. All right, now I can add. So I can add my fractions. 4 halves plus 1 half plus 1 half gives me 4, 5, 6 halves. My whole numbers. I have 3 plus 1 plus 6 plus 2. 6, 7, 8, 9, 10, 11, 12. I have 12 and 6 halves. Now what do I notice here? Because I cannot leave 6 halves as 6 halves. I cannot do that. It's an improper fraction. So what I need to do is I need to take this 6 halves, and actually it is a whole number. Remember, this means we're working with groups of 2. So how many groups of 2 are in 6? It's basically a division problem. 2, 4, 6. So this really, 6 halves, is really 3. Equals 3. So 12 and 3, 12, 13, 14, 15. This gives me 15. 15. How long did all the people surveyed watch TV combined? 15 what? 15 hours. All right, so again, we are taking all the things that we learned about fractions, and now we're applying it to our line plots. All right, let's look at another line plot. Let's look at the line plot first. Let's look at our title. So our title is Miles Students Ran Before Stopping. At the bottom, what do our numbers at the bottom, or our fractions at the bottom stand for? Our fractions at the bottom stand for the amount of miles that the students ran. Okay, we have 0 miles, 1/8, 2/8, 3/8, 4/8, so we're working with eighths on this line plot. And an x equals 1 student. All right? So, how many students ran 3/8 of a mile? 1. How many students ran 4/8 of a mile? I'm expecting you to say the answers. How many students ran 5/8 of a mile? How many students ran 6/8 of a mile? How many students ran 7/8 of a mile? How many students ran 1 mile? Okay, now we have to read the questions and use the line plot to answer the questions. How many students ran 5/8 of a mile? This is a 2-part question, notice also. 1 part, 2 parts. How many students ran 5/8 of a mile? 1, 2, 3, bam. Okay, so my first answer is 3. What is the total distance run by those students? So how am I going to figure that out? What is the total distance run by those 3 students? 5/8, 5/8, 5/8. Each of those 3 people ran 5/8. What equation could we write? We could write a repeated addition equation. I would rather see you write a multiplication equation. 5/8 times 3 equals 15/8. Then I need to see you turn that improper fraction into a mixed number. It's a division problem. 8 goes into 15 once, and you've got 7/8 left over. So, writing really sloppy today.